previous presentations clearly show the importance of including ecosystem services in different types and different levels of decision making. I'm presenting a study that focuses on one specific decision-making context, that is land use planning, and I will dwell more on the technical sides of it. I'll try to get that on the presentation. Okay, the study area is the Araucanía region in southern Chile that was selected because it has a very high value in terms of natural capital, but it's also considered among the poorest region of the country, affected by widespread poverty and a high reliance on ecosystem services as a subsistence livelihood. The other reason why we choose this area is that Chile just adopted a new law last year that, by the way, also introduced strategic environmental assessment formally, and introduced also a new form of land use planning at regional scale that include explicitly a land use zoning system, so a sort of spatial policy that determine the preferred land use for the whole region rather than for the urban area only, as was more common before. So we decided to focus on this specific stage of the land use planning process, the stage where alternative spatial policies start being developed, start being drafted, and need to be compared in order to find the most suitable way of action. This cartoon representation of policies simply means that was meant to represent the fact that those are spatial policies, so they look at how land use can evolve in the region. And I focus on modeling the effects of these policies on three key ecosystem services in the region, and these are the timber production, so a provisioning service, which is leading most of the changes in the area, and two regulating services, the conservation of soil, so retention, and the filtration and purification of water. The method is based on the framework you see here, so we use a lot of GIS modeling to first try to understand how the different policies will look like on the ground. This is because spatial policies at this scale are quite broad. They don't tell you exactly what is going to happen on every parcel. They just give different general directions. So we generate land use scenarios to try to understand what would be the likely implication of the policies on the ground. And on the following stage, we use the different scenarios for different time horizons to map the distribution of the three services I mentioned before. However, in this presentation, I'm not dwelling on the technical details of the modeling. I'm rather devoting the rest of it to discuss how we try to make sense of the results, how we develop metrics that could be provided to stakeholders and decision makers, and be helpful in basically answering three key questions that are first, the most obvious and straightforward. We are looking at the effects of different policies on these services, so we want to get an understanding on what policies seem to work best. So the spatial analysis allows us to construct this kind of diagrams that show, for instance, that through time, water purification services is bound to decrease, even though the pattern, the shape of this decreasing is dependent on the type of policy. So we can already get an understanding of what policies seem to cause at least the least damage in this case. However, we quickly realized that this type of information was not enough to fully characterize each policy because it provides only an average, a sort of aggregate evaluation at regional level. But it turned out that the green policy, for instance, was having severe effects locally. That's why we went more in detail and developed a number of additional metrics, among which the ones listed here, that try to look at what is the percentage of the land area, of the region area, that each policy is bound to, let's say, is bound to cause a hybrid degradation on, and on the opposite, what is the land area that each policy is bound to preserve in terms of the different ecosystem services. So the idea was to develop these metrics to provide a more complete picture of the effects of the different policies. And We then move to question number 2, which aims at taking a step further in the direction that has been very well described in the previous presentation. We basically try to figure out what are the effects of the changes in the services that we modeled before on the actual benefits, on the actual well-being. So this means that we have to move from the biophysical realms that we use to model the provision of services to the social cultural realms. So we need a sort of conceptual links between changes in services and changes in one or more components of human well-being. I just use, for the sake of simplicity, the human well-being framework adopted by the Millennium Ecosystem Assessment that suggests to use these 4 main components. So this requires, of course, to integrate in the analysis further data, and specifically socio-economical survey, poverty survey, livelihood analysis, census data, and to construct this conceptual link between changes in services and changing well-being. For some of the services, particularly the provisioning services, this is quite straightforward because they have a direct impact on the material assets or income, but the issue is far more tricky when we look at regulating services. That's why we try to develop proxy analysis, proxy indicators, like the one shown here, that try to link the changes in the service. Here you see, for instance, the effects on soil retention classified in a qualitative way, with changes in some variables that could be linked to well-being. Like in this case, we cross this information with information on the distribution of the percentage of households that rely on farming as a basic subsistence need. The idea is that obviously intense soil degradation will have different effects on households that rely on farming as opposed to households that rely on something else. And this is the kind of analysis that we try to develop to picture this link between the services and the benefits. The same thing we did, for instance, with water filtration, by looking at where people that do not have piped water live with respect to areas where that service, the water filtration service, is degraded. So this again allowed to come up with additional metrics, like the number of households with no piped water affected by a reduction in the water purification services. Assume that these people rely on wells, on surface water, so they need this service for health. Or the number of households that rely on subsistence farming that live in areas that are bound to be affected in terms of soil retention, soil preservation. And finally, the third question, perhaps the most relevant of all, looks at trade-offs. Trade-off is perhaps the big key issue in ecosystem services and also in planning. Planning is basically making decisions about trade-offs. So the study, the modeling allows us to understanding the relationship between 2 services at a time. In this case, show the typical pattern where an increase in a provisioning service, in this case timber, is followed by a decrease in a regulating services, in this case soil retention. So you can see that the different policies all follow the same pattern, even though with a different slope. So the green policy, for instance, caused an immediate decrease in soil retention, whereas the red policy, which is what economists would call at this point an efficient alternative, is the one with the smoother effect on soil retention. However, this type of trade-off analysis only focuses on trade-off among services, so what we gain in one service and what we lose in other services. It's important, of course, to take again that step further and looking at trade-offs among different groups of beneficiaries. In this case, this slide shows an example of the analysis that was performed that basically broke down the results at municipal scale to highlight situation of municipalities that are likely to be better off in the future, that because they will enjoy an increase in some services without any side effects, so to say, compared to municipalities, the yellow one, that will gain something but lose something else. And finally, municipalities that are bound to bear the cost of the land use choices because they will only experience some degradation without any benefits. And you can see the differences between the 3 policies For instance, this one tends to generate a sharper division of the region into areas better off and areas worse off, whereas the third one tends to produce a more smoother distribution of, let's say, of consequences of land use choice. The same analysis can be repeated, and will be repeated, as a matter of fact, by looking at different social groups. For instance, by grouping people according to poverty levels, by grouping people according to ethnicity, which is quite an important issue in this study area, even though I didn't mention it, or by grouping people according to livelihood systems, so on and so forth. So, in other words, this allowed to better understanding the relationship between the spatial pattern of provision of a service with the spatial pattern of use of that service, and especially to highlight the fact that a service generally matters in a different way to different groups in society. Concluding, this whole study was about understanding the relationship between land use choices, the biophysical provisioning of services, and finally the effects on well-being and on different groups of people. I think it's very important for this kind of analysis to be able to rely on multiple metrics. I don't think that the complexity of the issue can be captured just by one matrix, so we want to make sure that stakeholders as well as decision makers are provided with a whole array of metrics that in principle, ideally, should be guided by case-specific questions that we want to answer. So in some areas, poverty might be the issue. In some other region, you might want to look at, for instance, the relative inequalities in the distribution of the consequences. Some other area may require more intense analysis of the biophysical provision, whereas in other region, you may want to look straightforwardly to the effects on well-being. So the multiple metrics is a key factor here. And finally, the metrics that have been developed and the conclusion that have been drawn could be performed only because all the analysis has been spatially explicit. That means that we were able to come up with a spatial distribution of the services and also of the beneficiaries. However, this doesn't mean that we need to run complex GIS operations all the time. There might be cases where qualitative or descriptive analysis can work, as long as it is able to capture the complexity of the geographical relationship between the issues I mentioned before. Thank you.